Algebra 2. Today we're going to discuss Chapter 6.4, which is factoring and solving polynomials. So today we're just going to factor, and then in class we'll do the solving. And so this is different from the factoring you've done before because these are going to be things that are greater than just a quadratic. So an overview of what we've done before. In general, we factored trinomials into two binomials, but not necessarily. We have factored difference of squares. That's the only time really that we have done a binomial into two binomials, okay, because the middle term cancels if you have a negative AB and a positive AB. We've done perfect square trinomials, and we've always done greatest common factors. So those are the ones that you should be familiar with. And this first one here is just, your trinomial into two binomials, and you might use your AC method or you might use trial and error. So that's that one. What we want to add today is the sum of two cubes and the difference of two cubes. And this is just so if I'm adding two perfect cubes together, that it's going to factor into a plus b times a squared minus ab plus b squared. And you just need to write that down. It's one of those patterns that we're just going to use the pattern. Similarly for difference, if we have the difference of two cubes, it's going to factor into a minus b times a squared plus ab plus b squared. And definitely have those written in your notes. So let's look at using them. Here we have 125 plus x cubed. And I'm going to make it a little bigger for us. So you need to know that 125 is 5 cubed, and x is x cubed, or x cubed is x cubed. So this is the sum of two cubes. So just using our pattern, this is going to go in for a, this is going to go in for b, and our pattern for a sum of two cubes was a plus b times a squared minus ab plus b squared. So I'm just going to put things in where they go. So this is going to be 5 plus x. Okay, that's my a plus b. This is going to be 25 because that's 5 squared minus 5x because that's a times b plus x squared. So all I've done is figured out what a and b are and then plugged those in, and we're done. So let's look at the second one here. Well, this is not a difference of cubes because a to the fourth and a are not something cubed. But notice that that's a GCF. So let's pull out an a. Leaves us with 64a cubed minus 27. Okay, well, 64a cubed is 4a cubed, and 27 is 3 cubed. So here in the middle, do we have a difference of cubes? So the a is going to stay out front. So in the difference of cubes, this changes to a minus and this changes to a plus. So a minus b is going to be 4a minus 3. A squared is 16a squared. Make sure you're thinking about where I'm getting these here. It's a plus. A times b is going to be 12a. And plus b squared is going to be plus 9. And I was using 4a as my a and 3 as my b. If you didn't get that one, you really might rewind and play again. So that's going to be important that you know the placement of those numbers. So beyond those forms of factoring, if we have four terms, we can factor by grouping. So this doesn't say it, but you do need to have four terms. And we group by doing greatest common factor 3 times. So let's take a look at that. So here we have a 4-term polynomial. And I want to try then to factor by grouping. So I'm going to look at the first two terms. And by the way, it doesn't have to always be the first two and the last two, but Typically, textbooks are pretty nice about giving it to you that way. From these first two terms, do they have a greatest common factor? Well, they have an x squared. So I'm going to factor out an x squared, which is going to leave me with y squared minus 3. And then I'm going to look at the second two terms. What do they both have in common? Well, they both have a 4. I'm going to ignore my sign here real quick. If I just pull out a 4, it's going to leave me with a y squared and a 3. But if I pull out a positive 4, it's going to leave me with a positive 3. So I really want to pull out a negative 4 so that I get a positive y squared and a negative 3. Make sure, if you distribute, do you get negative y squared plus 12? And so the reason I wanted to pull out a negative 4 is because I need these two to be the same. You can only factor by grouping if those two are the same, and they are. That becomes your GCF. So you're going to pull y squared minus 3 out front. That's your third GCF, by the way. And then you write what's left, which is going to be x squared minus 4. Now there'll be times that you're done, but not in this case. What is this? That's a difference of squares. This first one isn't because of the 3. So we're going to leave the first one, and we're going to factor our difference of squares. That becomes x plus 2 and x minus 2. And a great way to check when you're done is you should be able to multiply that all out and get back to where we began. One last example. Here we have x to the 4th plus 4x squared minus 21. It looks very similar to the quadratics that we were factoring before, and that's good because we're actually going to factor it just like a quadratic. And in fact, anything that this is the square of this, you factor just like a quadratic. So because x squared squared is x to the 4th, we're going to factor this just like it was a quadratic. Because in a quadratic, you had x as your middle term and you squared it, and that was your first term. So if we did this by trial and error, I would actually set up x squared and x squared, like I would do x and x for a typical quadratic. So for 21 and then 4, I'm going to choose 7 and 3, and a positive 7 and a negative 3. And we should check and make sure, but that's going to give me an x to the 4th. 7x squared minus 3x squared is 4x squared, and I have a negative 21. And if by chance you ended up with a difference of squares or something, you would go on, but in this case we are done. Alright, so there's the factoring part of the section. We'll go over the graphing, not the graphing, the solving. We're going to solve. We will solve when we get back in class. Let me know if you have any questions, and have a good day.